All right, so continuing with the third, our help and tips file, continuing with this idea of trying to look at two variables in some graphs, let's do some scatter plots. Scatter plots are going to be the bread and butter with how we look at the relationship between two different variables. And you're going to be doing a lot of scatter plot work in terms of just graphing and looking at things before really you've run any models, just looking at a scatter plot and seeing what you have. And we'll be doing some other scatter plots later on with assessing a model once we're done with it. But really the scatter plot is probably the most useful plot that we will look at in this course. So again, I've got some more features here than you will need to use in this class, but I wanted to give you everything to play with. And we'll do a little bit with correlation at the end here. So, okay. So we've been working with this points per game variable for our NBA teams. Now let's say we wanted to look at the relationship between the number of wins that a team has in a season and its average points per game. So this is a pretty reasonable question. But you can see that I've sort of set up a situation where one of the variables is the response variable, number of wins, and the other variable is an explanatory variable, points per game. So what we're saying is, what explains the number of wins that an NBA team has? What goes into that? Well, one of the things that you would think would help explain how many wins a team has would be how many points it scores on average. So we would assume that there's some relationship there. And what we can do is just look at the scatter plot between these two things to see if we identify any kind of relationship. Okay, so to do any basic scatter plot, it's simply the command plot. And then you put in the variable you want on the x-axis first, and the variable you want on the y-axis second. Now when we graph things with our scatter plot, when we graph our situations, we like to put the response variable on the y-axis because we want to see how much change there is in the y variable, the response variable, when we look at changes in our x variable or our explanatory variable. So let's just do that basic plot of points per game and GW, which stands for games won in this season. And since I have closed out of this, I need to upload my data again. And there we go. Okay. Great. So here's our basic scatter plot. And before I get into all these other options, let's just quickly interpret what we see here. Again, this is the default in R, so there are no custom labels here. There's no custom title. The axes are default by whatever R has chosen based on the data. And just to be clear, remember that, again, each row is one team, and therefore each dot on here is one team. And we'll be able to label these points later on, but for now, let's just look at this as it is. So when we look at a scatter plot, there are a few things I want you to notice. Remember that our explanatory variable is down here. This variable, we are hoping, explains this variable. We are hoping that points per game on average explains the number of games won. So we can ask, as we go up in points per game on average, what is happening to the number of games won? Well, we can see right away it looks like a positive relationship. As points per game increases, it looks like the number of games won is increasing on average. So that's one issue. A second thing to look at is to say, great, so it looks like I have a positive relationship. How strong is that? Well, you can generally see this shape pretty well. It's not a perfect line. It's not a perfect curve of any kind, but it's not totally noisy. It's not just a big blob. We can generally see the shape. So, we could say, yeah, it's moderately strong. So we've got a nice moderately strong positive relationship here. One other important thing to ask is, does this relationship look linear? In other words, does it look like a straight line would explain these dots and fit these dots well? Or maybe would a curve fit these points better? Or some kind of exponential looking curve? Would that look better? Well, we'll get into all those other functional forms and curves or linear or not later on. But I just want you to have this first instinct when you look at this to say, does it look like a line, a straight line would do a good job fitting this? If so, then we'd say, yeah, this looks like a linear relationship. And I would agree with that. I don't see any curvature in here. So to me, this looks like a moderately strong positive linear relationship. Those are the three things I want you to look at every time you look at a scatter plot. And in terms of curvature, we'll get to some other examples in the future when that's the case. But that's what our scatter plot shows us. And you will do that sort of assessment every single time before you run a model. And the reason we do that is we want to visually inspect our data and try to see what kind of relationship we might have before we try to run anything. Looking at the relationships within our data like this helps us make a better initial choice for a model so that when we go to fit and assess, we start with probably better results and a better model than if we had just randomly tried variables that we didn't investigate or know much about. So I say, yeah, if I want to explain the number of games won in an NBA season, points per game on average looks pretty good. Okay, so what are some other options in terms of if we want to spruce up our plot? Again, this is if you just wanted to stop here with making your scatter plot, when I ask you to make a scatter plot, that's perfect. You don't need a title. I don't need you to change these things. Again, whenever you get into research situations or publication situations, then you will know you've got to make your titles, you've got to put on your axes. You'll do that within your own specific context. I just want you to be able to make the graph and to be able to interpret what's going on. But if you want to add titles and things, that's great. If you want to add a main title, just like we've done up above, you just add a comma after we enter in our two variables, and we use main again, and then the name of our title. If I want to add my x-axis label and my y-axis label, it's the same thing, x-lab, y-lab, and I just separate everything with commas. So that's good. Now, if I want to change, now you notice here, my limits on the axis, this is set to about 90 up to about 112. And for games 1, it's set to about, that looks like, 16 up to about 67, maybe 65. What if we want to change that? Well, we can add the option called XLIM and YLIM. That stands for limits. And so I can set XLIM equals to C, and the C tells R that it's going to have 2 points coming in. And I want to range from 85 to 115 on the x-axis here on points per game. And then similarly with the y-axis, I want to range from 10 games won to 70 games won, just because I want a bigger area to see this. I don't want to zoom in super closely on all these dots like this. So I set my endpoints for each of these things, and I run it, and there we go. Now it's rescaled. Now the relationship to me, this looks a little clearer to me because of how I've scaled these things. Again, you don't need to rescale, but maybe as you are investigating things, you want to do that. One other really neat option with the plot function is that after you've plotted something, and let's just start with the basic again here, you can add lines to it anywhere you want. And you can add lines at specific values, vertically or horizontally, or you can add lines that are a function of something. Like say I want to add the mean number of points per game scored, and I want to add that in here, or I want to add the mean number of games won as a line. You can do all that. Anytime you want to add a straight line to your scatter plot, you just use AB line as the command after the plot, and you run them separately. So you run your plot first, and then good, it's great, and then we can add our AB line afterward. When I want to add a vertical line, I just say V equals, and I set the value at which I want that line to appear. So let's add a solid vertical line at 100 points per game. There it is. Now, let's say I want to add a horizontal line instead. Let me clear that out. I can add a horizontal line by, again, doing AB line and using H equals and then setting the value at which I want to put this line. So I can put a line at 40, but let's say I want to use a dotted line. There's a style option called LTY. And LTY lets you set the type of line that's going to show up on your plot. You can do dotted and you can also do dashed. They just look a little bit different. So if I want to add a horizontal dotted line at games 1 equal to 40, there it is. Now those are predetermined numbers that I told are so that the line would go at a very specific number. What if I want my line to go at the mean of some variable? So for example, let's say I want to put a horizontal line at the mean number of games won. I can do that. I have my plot already up, and I can add AB line again, and just say H equals, and then this is called nesting. So I can nest the command to pull up the mean within this command to draw the line. So I'm going to nest this command of mean for the number of games won, and then also make it a dotted line. And there it is. And I know that this is at 41 because there are 82 NBA games in a season, and so on average, the number of games won will be half of that, or 41. So anyway, I knew that going into it. So there you go. One other fun thing you can do, you're never going to have to do this, but it might be useful, is you can label every single one of these points with whatever variable you want to label them with. So let's say I wanted to put the team name on these dots. Well, I know in my data set, I have the team name here, and that's a variable called team. So what I can do is I can just run another plot, and I'm giving it a title this time. And I can also then add this new command called text. And to do this, I simply copy the variables I have above for the plot command. And the trick is to add this thing called labels. And so it's labels equals, and then the variable that I want to label all these points with. In this case, I want to label it with team. These last two options are just style options. CEX is for size, and POS is for position. And I have that up here. So if I want to put those on there, obviously I'm trying to label a lot of points, so it's not going to look great. I might maybe want to make these a little bit bigger or try spreading them out. So I know you can't see this very well, but the point is to show you that, yeah, you can label all your points and see what's happening that way. So to wrap it all up, I can put all my options together and get a nice graph like this. And finally, I can find the correlation, which, remember, the correlation is the strength of linear relationship between two variables. And I find a correlation of 0.74. which is perfect, and that matches exactly what we see here, a moderately strong relationship. So COR. Thank you.